morning, Townview. Welcome back to Chemistry Online.
So today we're going to be talking about intramolecular attractions, also intermolecular attractions, but we're going to start with these. So you've seen these before. We discussed them when we got into covalent and ionic. I just wanted to bring them up again today, so let's take a look at them. So intra means within, and intramolecular attractions are going to be the attractions that happen between atoms. So they happen between atoms inside of a molecule. So inside of a molecule. So examples are going to be H2O. So you have hydrogens, and they're both bonded to a single oxygen. And then you have these lone pairs over here. So this right here is an example of an intramolecular attraction because it happens within the molecule itself. So it happens within the molecule. So there are two types that we've already discussed of intramolecular attractions. First one is ionic. The second one is covalent. So if I were to ask you what kind of bond is this, what would you say? That's a covalent bond. Good. If we were looking at something like lithium and chlorine, what kind of bond would this be? That would be an ionic bond. Now, when we talk about the attractions between separate molecules, that's going to be something else. The last type of intra is metallic, but we're not going to go over that one today. We're going to skip it for now, and we'll come back to it. Today's main focus is going to be over intermolecular attractions. So intermolecular attractions, these are going to happen between separate molecules. So here we have an H2O. Actually, instead of H2O, let's just do let's do HF. So HF, another HF, because hydrofluoric acid is a liquid. So you're just going to have a bunch of them side by side. And they're all going to be in this particular order because hydrogen is positive, fluorine is negative, positive, negative, positive, negative, positive, negative. All of these are going to be intermolecular attractions. So I'm going to change color just so y'all can see what I'm talking about. So the attraction between this hydrofluoric acid and this hydrofluoric acid, this is called the hydrogen bond. So over here we have another one, also a hydrogen bond. Over here we have another one, also a hydrogen bond. Now, what is a hydrogen bond? It's very similar to the hydrogen bond we were talking about before. The difference between this one and the last one is this one happens outside of the molecule itself. This also happens between fluorine, oxygen, and nitrogen. So NOF, just like before, and sometimes P. You guys don't have to worry about P. Just keep in mind NOF. We didn't really discuss why before, but the reason it's N, O, and F, it forms these really strong hydrogen bonds, is because they're so small. So they're up here at the top of the periodic table. So fluorine's the most electronegative. Right next to it, you have oxygen and nitrogen. These are all really small atoms, and they're really good at taking electrons away from hydrogen. So anytime you have a hydrogen bonded to one of these things, the electrons go really close to the nitrogen, and they form this really powerful bond. This really strong, difficult to break bond. The next type of intermolecular attraction is called dipole-dipole. Can anyone tell me what dipole means? All right, two poles. So basically, it means polar. So when you hear dipole-dipole, these are the attractions that happen between polar things. So polar. So let's say we have HCl. This is not a hydrogen bond. So HCl, HCl, HCl. The dipole-dipole bond is going to be this one right here. So this is dipole-dipole, and this is dipole-dipole. So they're bonds that happen outside of the molecule itself, and it just happens between positive and negative sides. So positive, negative, positive, negative, positive, negative, and so on. So what type of molecules have dipole-dipole attractions? Polar molecules. So if I were to say O2, is O2 polar? No. Does O2 have dipole-dipole attraction? No. Does it have hydrogen bonding? No, it doesn't have a hydrogen. So the next type is the only type that O2 would have, and that's going to be induced dipole. What does induced mean? All right, so it's a forced dipole. So O2, we were talking about before how it's the oxygens, they have the same pull on their electrons, which means neither one of them has a strong pull on the electrons. However, let's say we brought something that's polar, like HCl, and we know HCl is positively charged on this side, negatively charged on this side. What's the oxygen going to do when you bring something positive close to it? What are the electrons in the oxygen going to do? They're not going to bond. They're just going to move over to this side. They're going to come over here, and they're going to get close to it. And then the electrons that were here, they're also going to move a little bit over this way. So what does that do to this side of the O2? If the electrons are all sort of moving to one side. So this side becomes negatively charged, and what happens to this side? It becomes partially positive. So this is what induced dipole is. Induced dipole, it happens between things that are not polar, but it's just a forced polar attraction, and it happens because you're dealing with something else that's polar. So induced dipole is also referred to as London dispersion force, or LDF. And everything has LDF. So everything has induced dipole. So HCl has dipole-dipole. It also has induced dipole. O2 only has induced dipole. Hydrofluoric has hydrogen. It has dipole-dipole. And it also has induced dipole. So a thing can have more than one type of attraction. Any questions on these? All right, let's go ahead and move on. All right, so with regard to hydrogen bonding, hydrogen bonds are going to be the strongest type. You don't need to write anything here. I'll tell you what to write in a minute. So I want to zoom into this so y'all can see real closely. So over here, what kind of bond is this? It's a covalent bond. So the bond that happens between the atoms within the molecule, these are going to be covalent bonds. Now these temporary bonds that happen outside of the molecule, what do we call them? So in the case of H2O, it's happening between this hydrogen and this oxygen, so we have a hydrogen bond. So it happens outside of the molecule. That's the important thing to know about these. Now, it's the strongest type of intermolecular attraction. We'll talk about this on the next slide, but just know that with hydrogen bonding, it's very similar to polarity. You still have a positive side and a negative side. The only difference is it's much stronger than polarity. All right, so we already discussed all of this. Now, dipole-dipole, we already said that this happens in polar things. So anything polar has dipole-dipole attraction. And then lastly, we have induced dipole. And induced dipole happens everywhere. So this is the same example I showed y'all earlier. So this is the negative side of the H2O. This is the positive side of the oxygen because it's the opposite of how I showed it to you. All right, last thing I'm going to have you guys write about induced dipole attractions is they increase based on the size of the atom or the amount of electrons involved. So having more electrons move over to the other side creates a larger induced dipole. The way this was questioned on the last ACP was they showed molecules like this, and then they asked which one has the greatest London dispersion force. So what would the answer be? A, B, or C, or D? All right, so this has the greatest induced dipole. Which one has the least induced dipole? The smallest one. All right, do we all have that statement? All right, let's go ahead and move on. This is our final slide. All right, so let's take a look over here. This is all of the bonds. They're all side by side. So I'm going to write out examples of each. So for ionic, we're going to go with NaCl. This is regular table salt, the salt that you guys use in your food. That's going to be ionic. For covalent, I'm just going to put, I'll put H2O because that's going to be our covalent thing. And so for hydrogen bond, I'll use H2O again. And then for dipole, I'll put in CH4. We could also do CO2. I'll do CO2 instead. And then for induced dipole, we'll just do O2. All right, so when it comes to sodium chloride, which is regular table salt, what is the state of matter for table salt? Solid, liquid, or gas? Solid. When it comes to the water you guys deal with every day, what's the state of matter? So it could be solid or liquid. So if you freeze it, you're dealing with a solid, or it could be a liquid. When it comes to hydrogen bonding, we're going to call this one just a liquid because you don't really see them in the solids. It doesn't appear the same way when you're looking at ice, the hydrogen bonds. And then next up, we have dipole, or CO2. What's the state of matter you see CO2 in? It's going to be gaseous. Has anyone ever seen those solid, the dry ice? So it can be a solid. However, you're most likely to experience it as a gas. What about oxygen gas? Also going to be a gas. So when it comes to the strength of these bonds, if the bond is stronger, what does that tell you about the state of matter? It's going to be a solid. What if it's got a really weak bond? What's that tell you about the state of matter? It's going to be a gas. So if I ask you the question, which one of these has the highest boiling point? Actually, no. Which one has the highest melting point? What would it be? Which one is going to require the most amount of energy to take it from solid to liquid? Why NaCl? It is a solid, but that's not why. Because it's the strongest. It takes an enormous amount of energy to break the bonds between the sodium and the chloride. So because the bond is so strong, an enormous amount of energy is required to go from solid to liquid. Which one has the lowest melting point? Induced dipole. So this is going to have the lowest melting point because these things have hardly any attraction between each other. They don't even care to be attracted to each other. Which one is going to have the highest boiling point? Bless you. Which one has the highest boiling point? Which one is going to take the most amount of energy to take it from liquid to gas? Also ionic. Which one is going to have the lowest boiling point? Also induced dipole. Does this make sense? So the stronger the bonds, the more difficult it is to take it from solid to liquid to gas. I want you to understand the strength of these bonds. So the stronger these bonds, the more difficult it is to change the state. To go from solid to liquid, to go from liquid to gas. The stronger the bonds, the more difficult that is to do. The more energy that's going to be required.
If you don't know how to do chemistry, hit that subscribe button. Let's go!